Hello and very good morning to all. I am Mr. S.S. Sazni from Department of Mechanical Engineering, Sharad Institute of Technology Polytechnic, and I am teaching the subject Thermal Engineering. So we have now completed our theoretical part as well as some numericals based on this second chapter, that is ideal gases and ideal gas equation. So in this lecture we are going to see the important questions which have been asked in the previous last 3 Msbte papers. The first question from winter 19. So first we are going to see all the questions from this Msbte paper, that is winter 19 paper. And the first question we are having here: represent isochoric process on PV and TS chart. So this question is asked for 2 marks. And we have already seen all the process on PV and TS diagrams. So if we look at the first part, that is PV diagram, then you are supposed to represent the change in process in this way. So a straight line that will be parallel to pressure axis. So this diagram, that is pressure versus volume diagram, will get you 1 mark, and the second diagram, that is temperature versus entropy, this will carry 1 mark. So in this way, in the Msbte paper, any process can be asked and you will be supposed to draw the PV and TS diagram for same. So such question will always carry 2 marks. Now we'll see the next part. So the numerical was asked in the same paper for 4 marks. If you particularly look at the winter 19 paper for this subject thermal engineering, then this paper was having a very different format as compared to all the previous papers, because this particular paper was consisting so many numericals, and thus if you are not studying these numericals well, then such paper can put you in great trouble. Because right now only you can consider this paper where we are going to see all the questions. So in all these questions you can see that a lot of questions, that is numerical based questions, has been asked in this paper. So I request you all to thoroughly go through all the numericals and understand it properly, so that you can get good score even if numericals are asked apart from the theoretical questions. Also, there were a lot of mistakes in this winter 19 paper, such as there was some kind of misprinting, like for in this given example, instead of printing as 2 masses, they have printed it as 2 legs. So such kind of mistakes, or again they have also not given the essential parameters, such as the value of universal gas constant, which later on they told that the students have to assume. So this was the reason why I have asked you to remember the values for certain terms such as universal gas constant or characteristic gas constant. So you might require the values of same while solving these numericals, in case they have not given the values. Now let's see the numerical. So the 2 masses which was mistakenly printed as leg of gas contained in cylinder at a pressure of 7 bar and temperature 27 degrees Celsius expands 4 times its original volume at constant pressure. Calculate. First is work done by the gas, and the second one is heat added. So this question was asked for 4 marks. So we will see now the solution for this question. So here we are having the solution for this question, and in the starting part only you can see that there are 2 notes given. That is first regarding the printing mistake, that is instead of mass kg leg is printed, and the second note is the values of Cp as well as capital R are not mentioned in the question. Whatever the Msbte question and answers that we are discussing in this lecture, those are all taken from the Msbte model answer. So you can also get it download from the Msbte website. So if we look at our solution, then for the given question, first of all the given data has been noted down. So you can see that the mass of gas which was given, it is 2 kg. So here there was a big mistake because students were not able to understand that 2 leg of gas, and they actually want to say that there is actually 2 kg of mass of gas. So keeping all these mistakes aside, we will try to solve the problem. So the mass is 2 kg. Again, we are having here pressure. So the pressure is given, that is 7 bar, and temperature is given, that is 27 degrees Celsius. Apart from this, they have also given one statement, that is the volume of gas is expanding 4 times its original volume. And since all this process is occurring at constant pressure, so this constant pressure you have studied, it is called as isobaric process. So you can draw the diagram for a isobaric process, that is the PV and TS diagram, which are shown here. So these are the PV and TS diagram. You can also plot all the given data in this diagram, that is the change in process from state 1 to state 2. Now our first objective is to calculate the work done by gas. And for isobaric process, the work done by gas can be calculated by using formula W is equal to mR into temperature difference. So for temperature difference, we are only having the value of T1. So it becomes necessary to calculate the value of T2 first. So for calculating this temperature, we will take help of gas equation. So for two process, we will be using this gas equation, that is for initial condition. If we look at the gas equation, then it is represented as P1V1 is equal to R into T1, whereas for final condition, the gas equation can be written as P2V2 is equal to RT2. Now some of you will be asking that where does this equation come from? Then I would like to remind you that we have studied the characteristic gas equation, that is PV is equal to mRT. The same equation we are using here, just we are using that equation for the two conditions, that is initial condition as well as final condition. And if you look at the M parameter, then we have not considered, because here the mass is 2 kg, and since we are going to take the ratio of both these equations, that mass is going to be cancelled. So after having these two equations, we will be taking a ratio of these. So the next step we will be getting as V1 by V2 is equal to T1 by T2. Again, in the question they have given, that is the final volume will be 4 times of its original volume. So we are having here the value of V2 is equal to 4 into V1. So again, we will be substituting this value of V2 in this equation, so that the V1 will be get cancelled, and we are supposed to be finding the value of T2 for determining the work done. So just by rearranging, we will get the next step as T2 is equal to 4 into T1, and we are already having the value of T1, which is 27 degrees Celsius. So before substituting this value, we will be converting it into Kelvin. So adding 273 to it will give us a value of T1 equal to 300 Kelvin. And now we can substitute this value of T1 in the following equation. So we will be getting T2 is equal to 4 into 300, that is T2 is equal to 1200 Kelvin. So this is the value of temperature. Now we will calculate the work done by gas. So we are having here formula for the same. Work done is equal to mR into T2 minus T1. Now since we are having all the values, that is M they have given 2 kg. The value of R, it is necessary that you should note this value because it was not given in the question. So the value of R is to be taken, which is nothing but 0.287. and again the temperature difference, that is T2, which we have just calculated 1200 Kelvin, and T1 is 300. So after substituting all these values, we will be getting the work done is equal to 516.6 kilojoule. So here again one important thing, that is we are taking the value of R in kilojoules. So in our previous lectures you have studied that the value of R is 287, and here we have substituted the value as 0.287. So the reason for this is we are taking the unit as a kilojoule in this case. So if you are taking the unit in joule per kg Kelvin, then we were supposed to be substituting as 287, but since we have considered here unit as kilojoule per kg Kelvin, we are taking the value of R as 0.287. So if you are able to solve up till this part, then a total of 3 marks you will be obtaining. That is 1 mark for determining what equation we are supposed to be going to use. Again 1 mark for calculating the value of temperature, that is T2. Then 1 mark for calculating this work done, and the remaining 1 mark for calculation of heat added. So we can calculate the heat added by using the following formula, that is delta H is equal to mCp into delta T. So again the value of Cp they have not given, so here they have assumed this value to be equal to be 1. So mass we are having already 2 kg, Cp is considered 1, and temperature difference we have already seen what is this temperature difference, that is T2 minus T1. So we will be getting the value of heat added equal to 1800 kilojoule. So after solving up to this part, you will be getting a total of 4 marks. The next question from winter 19 paper. Again this question is asked for 4 marks. So the question is as follows: a nitrogen gas is expanded from 8 bar to 1 bar at 47 degrees Celsius according to law of PV is equal to C. Plot the process on PV and TS diagram and state the formulas to be used to find out the work done, amount of heat supplied, and change in entropy. After looking at this question, one will think that this is a numerical based question, but if you are carefully reading this question, then we can assume this to be as theoretical one, because we are not supposed to calculate any value here. Just they have asked to plot the process on PV and TS diagram, and we have to state the formulas for the process or the parameters that they have given. So let's see what is the solution for this question. As in the question they have given that the process or the gas is changing its state from initial condition to final condition according to the law PV is equal to constant. So here itself you should understand that the PV is equal to C. This process or this formula, that is PV is equal to C, you have studied in case of Boyle's law. So in Boyle's law we have studied that in this process, that is PV is equal to constant, the temperature is always constant, and if temperature is constant then we are calling it as isothermal process. So again they have asked to draw the PV and TS diagram for isothermal process, but they have asked this question in indirect way, that is directly they have not given that draw the PV and TS diagram for isothermal process, because rather it could be easier to understand. So you should have a thorough knowledge regarding this theoretical part, then only you will be able to attempt these questions. So for isothermal process, the PV and TS diagram will be as shown in this figure, and if you are able to draw these figures, then it will help you to get 1 mark. The remaining 3 marks will be allotted if you are able to write the correct formulas, that is for isothermal process, whatever the formulas you have studied for calculating the work done as well as the amount of heat supplied and change in entropy. If you are able to remember all these formulas, then you will get the remaining 3 marks. So we will just go through these formulas. The formula for work done, for isothermal process, it is given as work done is equal to R into T into log to the base E, and the ratio of pressure, that is P1 by P2. The next formula, that is for heat supplied for isothermal process, it is given as Q is equal to P1 V1 into log to the base E, again the ratio of pressure, that is P1 by P2. And the last formula for entropy for isothermal process, it is given as S is equal to M into R into log of the ratio of volume, that is V2 by V1. In this way, these two diagrams and these three formulas will help you to get the 4 marks for this question. Let's see the next question. That is again we are having numerical from winter 19. This question is asked for 4 marks. A system is composed of a gas contained in a cylinder fitted with a piston. The gas expands from the state 1, for which internal energy U1 is equal to 75 kilojoule, to state 2, for which U2, that is internal energy, is equal to minus 25 kilojoule. During the expansion, the gas does 60 kilojoule of work on the surrounding, and determine the heat transferred to or from the system during the process. So here, if we look at the diagram, then whatever they have given in the question, we are representing the given data in this diagram. So initially you can see that when the piston is at initial position, that is we are referring to state 1. At this stage we are having internal energy U1 equal to 75 kilojoule, and when the gas is expanding, then after this expansion at final state 2, we are having internal energy equal to U2 is equal to minus 25 kilojoule, and at the same time work is also obtained, which is nothing but equal to 60 kilojoule. As they have given the values of internal energy and work, and they have asked to calculate the value of heat, so we will use the first law of thermodynamics. So by first law of thermodynamics, we know that the summation of internal energy plus heat, it will be equal to summation of internal energy plus work, and the only unknown parameter from this equation is Q, that is heat. So by substituting all these values, we will easily get the value of heat, which is nothing but equal to minus 40 kilojoule. So if you are able to calculate this value of Q, then you might be getting up to 3 marks out of 4, because here you will be getting 1 mark if and only if you are able to explain the sign conventions. So in this diagram we can see that if heat is added to the system, then we are considering it as positive, whereas if the same heat is leaving the system, then we are considering it as negative. So since we have obtained the value of heat equal to minus 40 kilojoule, so this negative sign will indicate that heat is transferred from the system to the surrounding. So you will get this 1 mark if and only if you are writing what is the meaning of this negative sign. This entire numerical was based on just a single formula, that is first law of thermodynamics, and if you are able to solve this question, then easily you can get the maximum marks, that is 4 marks for this question. Let's move to the next question. So again there is one more numerical from winter 19, and the question is 3 meter cube of gas of 30 degrees Celsius and 6 bar pressure is expanded isothermally to 1 bar. Find work done, change in internal energy and heat transferred during the process. And the question is asked for 4 marks. So let's discuss what is the solution for this question. We can start the solution by drawing the PV and TS diagram for the asked question. So since they have given that the process is isothermal, we are having here PV and TS diagram for isothermal process, and whatever the data is given, we have represented this in the diagram. So you can see that the pressure, initial pressure, that is 1 bar, the final pressure as 6 bar. Temperature they have given 30 degrees Celsius. So all this given data we have noted down. Since the process is isothermal, the initial and final temperatures will be same. Since the temperature is in degrees Celsius, we are converting it into Kelvin. So the temperature will be equal to 303 Kelvin. Now to calculate work done, we are having formula for isothermal process, that is P1V1 into log to the base E multiplied by the ratio of pressure, that is P1 by P2. So just we have to substitute whatever the values we are having. So the P1 will be 6 into 10 raised to 5. Now you must have understood why we have multiplied this pressure by a factor of 10 raised to 5, so that the pressure is converted into its SI unit, that is Newton per meter square. Then this parameter is multiplied by volume, that is 3 meter cube. Volume is already in SI unit, so no need for conversion. And the logarithmic ratio of the pressure, that is P1 by P2, and we can substitute these values, that is 6 divided by 1. So after calculation we will be getting this answer as work done equal to 32.25 into 10 raised to 5 kilojoule. So if you get this answer, then you will be getting 1 mark for calculation of work done. Now again, the next part is we have to calculate change in internal energy. And for isothermal process, you should know that the change in internal energy is always 0. So you have to just mention that here, that is the change in internal energy equal to 0, as the temperature is constant. And for this you will be getting 1 more mark. The final part remaining is we have to calculate the heat transfer during the process, and for this we will be using the formula related to first law of thermodynamics, that is Q is equal to U plus W. Now since we know that internal energy is 0, we will be having again equation as Q is equal to W. And already we have calculated the work done for this process, which is equal to 32.25 into 10 raised to 5 kilojoule. So since Q is equal to W, here we will be getting the value of Q as same, that is equal to 32.25 into 10 raised to 5 kilojoule. So for this answer you will be again getting 1 mark. So in this way, this mark distribution I think you have now understood. Now we will move further for the next question. So the next question, again we are having numerical, which is asked in the same paper winter 19, and this is for 6 marks. So you can just imagine how much amount of numericals they have asked in this paper, and what might be the difficulty level for this paper. So the question is as follows: a mass of 0.8 kg of air at 1 bar and 25 degrees Celsius is contained in a gas-tight frictionless piston cylinder device. The air is now compressed to a final pressure of 5 bar. During this process, the heat is transferred from air such that the temperature inside the cylinder remains constant. Calculate the heat transferred and work done during process and direction of each in the process. So big question you are having, and depending on this question, the same kind of equivalent weightage it is also having, that is 6 mark. So let's see what is the solution for this question. So first we can see what is the given data. Initially mass is given as 0.8 kg, pressure is given 1 bar, pressure P2 it is given as 5 bar, temperature T1 it is 25 degrees Celsius. So after converting it into Kelvin, we will be getting value as 298 Kelvin. And again, the most important thing, that is they have given that the temperature is constant. So this process is nothing but we call it as isothermal process, and for isothermal process we know that T1 will be equal to T2. So for calculation the heat, we know that the formula, that is heat transfer delta Q, it can be calculated as follows. Delta Q is equal to M into R T1 into log to the base E, the ratio of pressure, that is P1 by P2. In this question they have not given the value of R, so you have to assume this value as equal to 0.287 kilojoule per kg Kelvin, and rest all the values we are having. So just after substituting these values, we will be getting the value of heat transfer equal to minus 110.11 kilojoule. So if you are able to determine this value, you will be getting 2 marks. In this model answer, which is given by Msbte, they have allotted 1 mark for writing whatever the given data they have given in the question, and it might be due to just determining that the process they have given is isothermal process. So I think that for mentioning that the given process is isothermal, they might give you 1 mark, because usually just for writing whatever the given data, you will be not getting marks. So for this determining which process they have given, they have allotted 1 mark, and for the calculation of this heat transfer, you will be getting 2 marks. After the calculations of heat transfer, you have to calculate work done. So the work done will be calculated as follows. Delta W, that is work transfer, it is equal to delta Q, that is heat transfer. So for isothermal process, if you are knowing this, then you can directly get the answer for work done. So we will be having delta W equal to minus 110.11 kilojoule, and for this you will be getting 2 marks. Now the last part remaining is regarding the direction of each process. So you will need to explain regarding the direction of heat transfer or work done either by the system or on the system. So we are having here explanation as follows. Work done is negative, which means that work is done on the system from the surrounding. And again, related to heat transfer, we know that since heat transfer is negative, it means that heat is transferred from system to the surrounding, that is heat is rejected from the system to the surrounding. In this way, if you elaborate the direction of the heat transfer as well as work transfer, then you will get the remaining 1 mark for this question. So in this way, a large weightage for numericals was given in this Msbte Winter 19 paper. The second chapter, that is ideal gases and ideal gas process, was contributing about 22 marks in this paper, out of which I think that 6 marks was based on theory, whereas 16 marks were totally dependent on these numericals. So from this paper itself, you should understand that how much efforts you have to take so that you will be able to solve such type of numericals in the paper. And also, after going through today's lecture, you will might not face any kind of problem while solving such type of numericals. So we will stop here for today, and in the next lecture we will see all the questions from the remaining 2 papers, that is summer 19 and winter 18 Msbte paper. Till then, thank you very much.